What's up, everybody? We're back with 9.2, and 9.2 is all about something called logarithmic functions. And if we were actually in the class, well, this is called logs for short, and actually there's a log button on your calculator right here. If we were actually in the classroom, I would actually bring in like physical laws with all the rules written on them. But what a log is, a log or logarithm is just the exponent that a specified base must be raised in order to get a certain value. So we have exponent form, and we have log form. So for exponential form, we have exponents, and we have b raised to the x power gives us a. And for this, b is our base, a is our value, and x is our exponent. So if you want to think about it, the base, this is our base, being raised to some exponent equals our value. And if I want to put this in log form, it's going to be log form has a log base b, it's little b, a is equal to x. And the letters or the variables still represent the same thing. This b is our base. This a is our value. And this x is our exponent. So I'm going to write this up here. We have a special rule. Star this, do whatever you need to do. If a log does not have a base, then the base has to be 10. Kind of like if you just have x, technically this is just 1x. Well, if I just have log, technically this is log base 10, unless specified other words. And you may be thinking, hey, this is dumb. Why do I have to learn logarithms? What are they even used for? Well, think about it. Exponents are they get pretty big. If you do like 3 raised to the 10th power, that's a pretty big number. Actually, I'm going to do that. 3 raised to the 10th power is 59,000. So, and that was just 3. Imagine doing like 10 to the 1,000 power. Well, logs are a way that you can kind of simplify it. And so, especially like in computer programming and stuff, so you don't have an overflow and your computer crashes just trying to figure out the number. I'm going to air this out. So I'm going to write our rule on the top. So remember, b raised to the x power is equal to a. That's an exponential form. If I want to turn to log form, I have log base b, a is equal to x. So for numbers 1 through 4, I'm just going to be switching forms up. So for number 1, if I have 9 raised to the second power is equal to 81. You say that's true, right? 9 times 9 is equal to 81. If I want to turn this to log form, I'm going to say first log, I'm going to see, hey, log base b. What's my b in this case? What's being raised to the exponent? It's 9. 9 is my base. And then a is my value, 81, is equal to x, which is my exponent, too. So a 9 squared equals 81 in exponential form is log base 981 equals 2 in logarithmic form. Number 2, I have 3 raised to the negative 3 power equals 1 over 27. Well, first, negative exponents. If we remember correctly, this is really, remember negative exponents, it goes on the bottom. So if I do this, is log base 3, 1 over 27 is equal to negative 3. That's it. So let's switch this up a little bit and let's try changing from log form to exponential form. If I have log base 9 of 729 is equal to 3, if I change forms, well, let's go from here to here. First, log base b, so I want b. What's my base? 9. Raised to the x power, well, this is whatever it's equal to, 3, is equal to a, which is right here, 729. So 9 raised to the third power equals 729. Well, let's figure this out. Put in your calculator. 9 raised to the third power is indeed 729. So that checks out. And number 4, numero quattro. I have log of 1000 is equal to 3. Well, this is weird, because if I'm changing from log to base, I should have log base b. I don't have a b here. And what do we assume that our base is when we are not given a base? That's right, 10. So 10 raised to the third power is equal to 1000. Double check that, make sure that's good. 10 raised to the third power, it is 1000. 10 times 10 times 10. I should get sponsored by Windex. I use it enough with this stupid board. Somebody tweet them. Tell them to sponsor me. Never got a call back from emergency to sponsor vitamin C. What a shame. Alright. So, if I want to evaluate, I got a couple of steps. Step number 1. I'm going to change it into an equation. Step number 2. I want to change this in an exponential form. And then I want to solve for x. So let's look at a few examples. So number 5, I have log base 2, 8. This isn't dry yet. This is ridiculous. Yeah, it kind of worked. Okay, log base 2, 8. It's not equaling anything. First thing I'm going to do is I'm going to set this equal to x. We want to set it equal to some variable in order to make an equation so we're actually able to solve this. Step 2, we're going to change this to exponential form. This is log form because there's a log here. We want to turn it into exponential form where there's an exponent. So I'm going to have 2 raised to the x power is equal to 8. So we're going to have to actually break this thing down. If I have 8, I'm looking, seeing, hey, how many 2's are in here? How many 2's? Well, 2, 4, 2, 2. I have 1, 2, 3 2's. X is equal to 3. And if you're not sure, plug that in for x. So if I do 2 raised to the 3rd power, I do get 8. This checks out. X is 8 here. And then finally, no, this is just number 6. I'm going to do number 6 here. Number 6, I have log 1000. I'm going to set it equal to x first. I'm going to change this to exponential form since there's no base. I assume that the base is 10. Equals 1000. I got to find what x is, so I'm going to do 1000. I'm going to see how many 10s, so I'm going to divide it by 10. So 10 and 100 make 1000. 100 breaks down to 10 and 10. 1, 2, 3 10s. X is equal to 3. If you're not sure, double check. 10 raised to the 3rd power in your calculator gets you 1000. Alright, number 7, last one. I have log base 4, 1/4. Now we're dealing with fractions. Fractions are your friends. They're not mean, they're just misunderstood. Set it equal to x. I have 4 raised to the x power equals 1/4. Here's what you're going to have to do with this one. This 4 is really raised to the 1st power, right? If I move this up, 4 raised to the x is 4, -1. Whenever you have negative exponents, remember, this is really equal to 1. We flip. Say, hey, if I have negative, I move it down to the bottom to become positive. If it's negative on the bottom, I move it up to the top to become positive. We're just flipping between numerator and denominator. So x is -1. And if you're not sure, let's put that in your calculator. I got 4, and I'm going to raise that, 4 raised to the -1, 0.25. Math, enter, enter, 1/4, boom, it works. That's all we have for today. I know it looks weird. This whole unit's gonna look kind of weird, but a lot of it's properties that we've already learned, and we're just kind of applying it to something else. Please let me know if you have questions.